Okay, moving forward. Money. So yeah, we don't have generally in the mining industry people swinging around, huge volumes of money to just start projects, right? There are a couple of like massive kind of global mining companies, Rio Tinto, Kennecott, um, Barrick Gold for that matter. Um, those companies have huge amounts of money, but most of the time, this work is being done by what are called junior mining organizations. So they're a smaller company, but they have a resource and they've done all of the work that we've outlined so far. And they're saying, okay, what's going to cost us, you know, $700 million to develop our mine. But once that's happened, our mine is going to be generating this amount of money. And so when mining companies are in the exploration phase, typically their stock value is very low. So if they have a viable project, so they say, here's our project, here's what we've pulled out of the drill core, come and look at our core. You can inspect it yourself. I'll show you a picture of that in just a second. Um, and then investors show up. This is really the kind of the tricky side of what we would think of as kind of economic geology, right? So if you are a junior mining company, you, well, what's the best way to explain this? Listing a stock in the United States on the New York Stock Exchange, as you can see in this picture, your company generally has to have a minimum value of about $1 per share before you can list in the States. That puts most companies out of the running. In Canada, it's much different. So when you really start paying attention to mining companies, most of them, if not all of them in the United States that are small, are actually all incorporated in Canada because the Toronto Exchange you can list if your company is valued at a nickel. Um, I think Phoenix Copper, which is going to be starting the mine up in Mackay, Idaho, in the kind of next decade, they're currently on the Toronto stock market for just about a nickel a share. Um, as their company grows and they reach that threshold value, they oftentimes unincorporate in Canada, reincorporate in the United States, and then list on the New York Stock Exchange. So again, as you're following mining news, maybe you'll pay attention to this stuff, maybe you won't. One of the most common complaints that people have is like, what the hell is this Canadian company doing in here mining all this stuff in Idaho? And the answer is that's where they're located. That's their office, that's their mine, but they can't make money unless they list in Canada. That's again, there's a lot that we could pick apart there. Either way, they have to raise money somehow to do the project. And if you get into, let's say you put money into Phoenix Copper at 5 cents a share, and 10 years down the road, Phoenix Copper is worth $8 a share. You did pretty damn good. And that's kind of the realm of economic geology. That is not financial advice. Serious. Um, so this is over at Integra. This is out in the Owyhees, and Integra is currently in that stage. I think they're American now, so yeah, it was like $1.50 a share, maybe is what Integra is at. Um, but this is their core shed just outside of Jordan Valley, and you can see all of this core is available to investigate. If you're an investor and you're really interested in what's happening and you really want to know, you can come and visit the site. This is Sarah Clark, a geologist up there, kind of giving some CWI students a tour. And you can look at the materials yourself. You can actually look at the core, do the assessment, and decide, is this something I want to invest in? And this is all of the geochemical analysis paperwork that goes along with the core. So following all of that, you got to build a mine. And building a mine isn't digging a hole. Well, it is eventually, but initially it is core shed, water treatment center, um, housing, offices, all of those sorts of things. And so most mines have kind of a 2 or 3 year construction phase once all the permitting has happened and once they've gotten into the clear in that sense. And you can see here, this is, a big water tank. Most all the water has to be treated before it's released. And again, baseline characterization, there's all of these benchmarks that the water quality has to meet before you can release it. We can't just dump toxic water like we used to. Um, and then following construction, we have extraction. So this is over in the Phosphoria Formation, the phosphate patch in eastern Idaho and Wyoming. Extraction is pretty straightforward. At this point, you're taking the ore mineral that contains whatever you're after, and you're literally digging it out of the ground. But it doesn't end there, right? Obviously, that gets a little bit more complicated, depending on whether you're doing an underground mine or a pit mine like you see here. You've got these benches and all these things. We don't need to talk about mine design. But the first step is a really fancy word, comminution. And in the process of comminution, we basically make big rocks, little rocks, right? So anytime you watch like a pickup truck commercial, something like that, they're always blowing rocks up. So many pickup truck commercials are filmed in mines. I have no idea why. They're like dumping gravel into the bed of the truck and watching its shocks react. But oftentimes the first step of making big rocks, little rocks is literally blowing them up. That's pretty exciting, as you can see here, blasting work. But once we've gotten to that stage, we need to take that material and essentially we're going to grind it down to a powder, a really, really, really fine powder. We're good at that now. We used to not be very good at it. So on the right, you can see this is an old, what's called a stamp mill. And this wheel would turn. And as that wheel turns, there's an axle that comes through the device here, and it lifts these pillars up, and they have a big weight on the bottom. And then after it's lifted up, it comes dropping back down and just smashes rocks. And so you can see there's a little chute that comes off of the end. So rocks will be sent through this thing with these hammers stamping, right? That's why it's called a stamp mill, crushing all the rocks into smaller and smaller and smaller little pieces. You take that material, you may run it through 3 or 4 times until you get it to be really, really fine. And at that point, the little tiny minerals are going to be able to be separated, right? So when we're talking about modern mining, you often can't see the metals in the rocks. They're much smaller than the naked eye could see. Things where you have big gold nuggets, that stuff was all done 200 years ago. You can see here's a modern crusher down there. This is kind of 3 different types of modern crushers. This one on the left is a jaw crusher. It crushes rocks like this, smashes them, and again, you may run it through 2 or 3 times. Any of those of you who have worked in the coffee industry may recognize a burr grinder. So we use them to grind coffee. Way better than the little spinny blade one. Those ones are not worth your money, but a good burr grinder. It lets out rocks of a predetermined size, right? So that's the gap here as this piece kind of wobbles back and forth and spins, and there it crushes the rocks. And again, you may have to run it through multiple times. In a mining operation, crushing rock is, I'm probably gonna get this number wrong. I think it's about 60 to 70% of the electrical or the energy requirement to run a mine is dedicated to crushing rocks, right? So from a power point of view, this is really, really, really electrically intensive. Far more than what you could cover with solar. So, many mines are in really remote areas, and they're like, we could put up a solar grid. It's not enough electricity to run these sorts of operations. Although some mines have started talking about putting in little small modular reactors to generate their electricity locally rather than running power lines, in some cases, for 200 miles to get out to your site. Anyway, here's another method of doing that. This is basically a giant rock tumbler. This is what's called a ball mill. And in here we add ore. And with that, we actually add a variety of sizes of big metal balls. Steel, probably not iron. Iron is too brittle, but steel balls are added, and then the whole thing is rotated, and you can see what happens here. It kind of works like a clothes dryer where it has those like I don't know, blades. They're called lifters, I guess, looking at the diagram here. And as it rotates, it lifts the rock material up and it lifts the big metal balls up, and then gravity drops them back down. And so we have these steel balls dropping back down, smashing into the rock material that's on the bottom of the drum. And that turns and turns and turns, and it creates this really fine grained material.